Hello everyone, welcome to EWorks, and in this tutorial we are going to learn about basics of assembly modeling in SolidWorks. We will start by modeling the individual parts of the double pendulum and then combining those parts into a single assembly. There are two different ways in which we can assemble a model in SolidWorks. The first one is called this bottom-up assembly, and in the bottom-up assembly, what we do is we create individual parts of the model. For example, part 1, part 2, part 3 in the part module of SolidWorks, and then we combine these parts into a single assembly under the assembly module. So this approach is called the bottom-up assembly approach, in which we start from parts and go to assembly. There is another approach which is called the top-down approach or the top-down assembly, in which we start with the layout of the assembly instead of creating the parts first, and then we create parts from the assembly layout that we created and combine those parts based on the layout that we have. In this tutorial, we are going to use this bottom-up assembly approach. Here you can see a simple pendulum, and it consists of three different parts. The first one is this wall mount, and the dimensions of the wall mount are shown here with the fillets and the center hole. The second one is the pendulum, and I'm going to create two different configurations of the same pendulum, and we have learned about creating different configurations in previous tutorial. We will create a single part with pendulum name and create two different configurations. The first one will be this top configuration with the hole at the bottom, and the second one will be the bottom configuration without any hole. And finally, you can see that there are pins that are combining the top configuration with the wall mount and also the bottom of top configuration with the bottom configuration. Let's shift to SolidWorks and create this wall mount. This is the SolidWorks part modeling window, and I'm going to create the wall mount. Selecting the front plane and going to sketch, I'm going to create this center rectangle with a dimension of 100 millimeter by 25 millimeter. The next step is to extrude this rectangle along the center plane by 10 millimeters. As a next step, we can add a center hole. The diameter is 5 millimeter for the hole, and this is through all. Finally, we can add the holes for wall mounting using this hole wizard. The hole is a countersink with NC metric dimension, flat head, and its dimensions are M0.25. I'm going to position this hole along this horizontal line and finally dimension this 15 millimeter from the corner. Finally, I can mirror this hole along the center plane, which is this right plane. Selecting the right plane as the mirror plane, and this is the feature that I'm going to mirror. Press OK. And one last thing is remaining, which is the fillets. So we have 10 millimeter fillet on these edges and a 2 millimeter fillet on the front face of the wall mount. So here we have this wall mount, and the back side it's flat without any fillet because it's going to be connected to the wall. I'm going to change the view to plain white. We have this one, and we can save this. The next part is the pendulum. I'm going to close this one. Click on new part, creating the new part, and the dimensions are set to millimeter gram per second. Going to select the front plane, click on sketch, and again I will draw this center rectangle. Let me check its dimensions. So they are 200 millimeter by 25 millimeter. and the extrude is 10 millimeter along the midplane. The next thing is to create the hole, which is going to connect this pendulum with the wall mount. I'm going to sketch this hole along the vertical line. The dimension of the hole is 5 millimeters and it is 15 millimeter from the top face. We can use extrude cut to cut this hole along both sides through wall. And finally, I can mirror this extrude cut for the top configuration. So what I can do is use this mirror tool, select the top face and select the cut extrude feature, which is here under features, to mirror it. And finally, we can add the fillets. So 10 millimeter fillet along these corners and a 2 millimeter fillet here on the front side and also on the back side of this pendulum. I'm going to edit the previous fillet and will add this portion as well. So we have this fillet here. In the previous tutorial, I showed how we can add the configurations using the design table under this insert tool. There is another way we can add configurations if there are like one or two configurations only. We can simply go to this configuration tab and click on the part, and after clicking on the part, the tree will open. Here you can select add configuration. So I'm going to name this as top configuration. Here you see this top configuration is active for now. The next step is add another configuration, and I'm going to name this as bottom configuration. So what is different in the bottom configuration? After activating this, I can go back and I can suppress this mirror feature here in bottom configuration only. So this is suppressed. So in the single part, we have, so if I activate the top configuration, you will see that it has both the holes. And if I activate the bottom configuration, it has only the top hole. I'm going to save this as pendulum. And the last part is to create the pin. So here again, I'm going to select this front plane, click on sketch. So the hole diameter was 5 millimeters. So I'm going to draw this pin of same size without taking consideration of any tolerances for now. And I'm going to extrude this by 20 millimeter since the pin will combine both the parts. The next step is to create the head of the pin, selecting this top face, sketching on this one, change its dimensions to 6 millimeters, and I'm going to extrude this by 3 millimeter. So the final thing is to add the dome on the top of the pin. So one way to create dome on the top is to select this top face and then create a sketch and revolve it around this portion to create the dome. SolidWorks come with some advanced features and we can have multiple tools. So under the tools, you can go to customize menu if the dome is not available. And in the features, you can see a lot of tools and under the commands. And if I go to features, you see that there are a lot of these commands that are available but not shown here. And one of them is this one, which is dome. And it can add the dome at the top of planar or non-planar surfaces. One way to use is to go to this portion here. You see, we can search the command SolidWorks help, and other details here. clicking on command and searching the dome, it will appear here, and I can select this command from that search bar. I'm going to select this face. You see that the dome with diameter of 10 millimeter is added. So this is 6, and this is 3 millimeter dome that we have added. And here we have this pin, and I'm going to save this pin. Now, the last part is to combine all these parts into a single assembly. How we can do that? You can click on the new tab, click on assembly. Here we can import the parts that we have created and combine those parts into single one. This is the general layout of the assembly tab that we have in SolidWorks. And here on the left side, the SolidWorks show two parts here, which is pendulum and pin. Since they are both open here and I didn't close them, they are appearing on the left side. But in case some parts are not appearing, I'm just going to close this. So this is the general interface for the assembly. And at the top, you can see the bars. Here you can insert different parts, components, and new assembly into this assembly module. And then this is the second and most important command which we are going to use. And using this, we can move the component or rotate the component that we have added. And finally, there is this made command which is grayed out. We will use this to combine two parts, and we are going to add multiple joints using this command. Before importing the first component, I want to see the origin here. So this is the origin of the assembly. So it's better usually to add the first part on this origin so that we can have some sort of reference which we can use later in the assembly as well. So this way the faces of the part that we are going to insert and the planes in the assembly, they will like coincide with each other. So the first part that I'm going to insert, I'm going to browse this instead of clicking on this. It's the wall mount. So when I select this wall mount, you see that the picture of this wall mount, it is appearing, and I can move this with the mouse. So if I hover this wall mount exactly over the origin, you will see that the coincident made feedback button is appearing. I'm going to click this. So the first part is usually the reference part, and we cannot move or rotate this part. This is fixed with the origin. The next step is to add the pendulum. So I'm going to browse this again, click on pendulum. You can see that the bottom configuration of the pendulum is appearing in the assembly. I just click somewhere in the assembly, and now if I go to this move component and select this, I can move freely this pendulum, and I can rotate this as well. So you see that uh, this is free, and we need to add few mates so that we combine this with the wall mount. So the first thing that I'm going to do is convert this bottom configuration to top configuration. So since we have created multiple configurations from the same part, what I'm going to do is right click on the part in the assembly, and here you will see this properties button. And in the properties button, you can see the activated configuration. So which is the bottom configuration here. I'm going to select the top configuration and press OK, and the top configuration for this part has been added. So the next step is to combine this pendulum with this wall mount. We can do this using this mate feature, and when I click on this mate feature, mate button, you see that several different standard mates have appeared which are coincident, parallel, tangent, and concentric. So this is how this works. So what I want is I want the this phase of the pendulum to be coincident with this phase, And you see, simply by clicking on those, this tab appears and I can press OK. Now, if I try to move this, I can move it along the single plane. Like this will be always in contact with the wall mount, but it is still free to move. The second one is to connect the circles or the holes of both parts. I'm going to select the center portion or the hole in the pendulum and also the hole in the wall mount. And you see that this concentric mate appears, and we have the top portion of the pendulum in place. I'm going to click OK. Okay, and we have the information related to mates here under this mat tab, under this mates tab. And if I try to move this pendulum now, I can only revolve it. You see that this is completely connected to the wall mount. The next step is to add another instance of this pendulum and connect that to the top configuration. If we need a copy of the same part in the assembly, we can do is we can press Control on the keyboard, click and drag the mouse along the way and release it. So you see a copy of this pendulum is created. However, this copy, it is still in this top configuration. I need to change its configuration to bottom like this, and we can add the mates. So for this bottom configuration, I want this inside face of the top configuration to be coincident with this face of the bottom configuration. And the second mate that I need is to combine the holes. I'm going to select this and this, and they needs to be concentric. You can see that. So when I close this mate option, we will see another two mates added in the tree, and now I can revolve this whole assembly by selecting and moving, and you see that it can move in 2 degrees of freedom setup. And the final thing is to add the pins at these two spots. I'll repeat the process, go to insert components, and now I'm going to select the pin from this tab. So selecting pin from this tab, I can go here, and now for the pin there are again two different mates. The first one is pin, this cylinder of the pin needs to be coincident with this hole, so concentric with this hole. And the second portion is this seat or this head needs to be coincident with this top face. So here we have this first pin. I'm going to close the mate, making a copy of the pin. So I have created the copy of the pin here, and I'm going to add mates again. This cylinder with this face, and finally you will see that this face is combined with this face. So that's the whole assembly that we wanted to create, and I'm going to move it like this, and I can freely move the system now. So this is the complete assembly of the double pendulum that we have learned in this tutorial. Thank you for your time, and we will come back with the new tutorial soon.